Hi everyone. Let's go over that last classwork problem slowly and carefully. So here's a function. It's got a domain restriction, so we're only looking at values where x is less than or equal to 2, and we're going to find the inverse in its domain. So let's pretend that we don't know so much about the domain restriction, so we're just going to sort of proceed as usual. So you guys usually swap the role of x and y, and then solve to isolate y to find the inverse. So let's see what happens when we do that. So I'll subtract 2. I'll take the square root on both sides, and I'll subtract 1. So here I've got -1 plus or minus root x minus 2 equals y. Okay, so the question is, does this work as an inverse function? And I'll show you immediately why it doesn't. So if I plug in an input value, for example, let's do 3, I'll get -1 plus or minus root 3 minus 2. Okay, so what's that? So 3 minus 2 is 1, so that's -1 plus or minus root 1 is 1. But the plus or minus is really shorthand for you're allowed to do plus, and that produces an answer, and you're allowed to do minus, and that also produces an answer. So on the plus branch, I'll have -1 plus 1 is 0. On the minus branch, I'll have -1 minus another 1 is -2. So what we have here is we have a single input, but we have 2 outputs. And that's not allowed in a function. The defining feature of a function is a single input can only produce a single output. So this is not a function. All right, so maybe that's why the domain restriction comes in. It's because this thing isn't a function. So let's think about this graphically. I see it's a parabola. I see it's been left shifted by 1 and shifted up by 2. So let's draw that. So here's what the original f function looks like. This point is -1, 2. This point is going to be at -2, 3 right here. And this point is at 0, 3. Okay, so you might remember that inverses are reflections around the line y equals x. So what would this look like if I reflected the entire thing? So this vertex at -1, 2, if I reverse the x and the y coordinates, is going to map to 2, -1. So that point ends up here. The 0, 3 maps to 3, 0. So this point ends up here. The -2, 3 is going to end up at 3, -2. And so now I can connect them. Okay, so this reflects here. And now we can see what this input was about. When the input was 3, we got 0 and -2. But that's exactly what's happening in the picture here. With an input of 3, we have outputs at 0 and also -2. And so that's why this ends up not being a function. Okay, so what role does the domain restriction play? We're not looking at the whole parabola. All we really care about is the part of the parabola where x is less than or equal to -2. So that's starting here, going this way, just this piece of it. So it's as if, this is supposed to be an arrow, so it's as if the rest of this parabola isn't even there at all. So where does this green shaded part end up over here? So if this is sort of the end point at -2, 3, here's that same endpoint at 3, -2, and it ends up over here. So I'm interested in modifying this equation so that it only covers this shaded part, because that's the only part of the original parabola that is actually part of our function, because we intentionally said we're only looking at part of it. Well, okay. Remember that the plus or minus created 2 different answers. There was sort of a positive branch and a negative branch. So you can imagine this sideways parabola is divided into an upper branch and a lower branch. We've got the -1, which is kind of this midline here, down by 1. And then from the y value of -1, we're either going to add some amount or subtract some amount. And so that's what produces those pairs of values. So which branch do we want to keep? Do we want to keep the upper branch or the lower branch? And then what does that correspond to? Does that correspond to the plus root or the minus root? So it seems like we want to only keep the lower branch here. And we got to that lower branch by subtracting from the -1. So I'm going to modify this equation so it's not plus or minus, it's -1 minus x minus 2. Okay, so that's a lot better. So now we only have one of the branches of the sideways parabola, and now we've got a function again. But it's not quite right yet because we need to find the domain. And the domain isn't actually including from the vertex all the way over. The domain only starts at the part that we'd reflected. So remember, x and y change places, but the domain and range also change places. So here for f, the domain was x less than or equal to -2. The range is 3 and above. So y values are greater than or equal to 3. If you see over here, this part, if I think what x values are part of this curve, I've got x values starting at 3 going up. So greater than or equal to 3. And you'll notice that matches this range, y greater than or equal to 3, because the y values became the x values when we swapped them. So the fully correct answer would be to say, well, here, let's write it with the right notation. The fully correct answer would be to say f inverse equals -1 minus root x minus 2 for all x values greater than or equal to 3. Okay, so what's the big takeaway here? Definitely do whatever process you do to find an inverse, but in order to figure out the domain restriction, you have to actually think about it graphically. Think about what part is part of the original graph we want to be reflecting, and then how does that part reflect, and then just look at what's the domain of the reflected part. And that'll help you modify what you would have gotten so that you know, 1, that it's a function, and 2, that it's got the correct domain. Okay, hopefully that was clear and more helpful.